Let's do this thing! I present to you a common ground debate between myself and a guy named Ben on our debate board. We've been having a lot of discussions lately concerning Newton's second and third laws, and something called net force. Here I want to highlight one of them that I feel really embodies the essence of what a common ground debate is. Essentially, it is a series of do you agree questions, something you just don't see enough of in traditional debates you see everywhere else online. Here, our objective is to actually persuade your opponent. We do this with a series of stepping stones. We start off with some really basic common ground, and then we add to that and see if we can't lead someone along our own line of thought to come to our same conclusions. When we establish common ground, though, it very much works two ways, and they are very much encouraged to ask us similar questions to try and dissuade us into their line of reasoning. So let's begin! In college, they taught me to kiss, which means keep it simple and stupid. So here we go. I suppose I should start with some background to my question. Here, when looking at this dumbbell on the floor, I claim if force equals mass times acceleration, then this stationary dumbbell should not weigh anything, since it is not accelerating. Hereby, I disagree with Newton's second law of motion, since even though the dumbbell is not accelerating, it is still exerting a force upon the floor, which should be impossible according to Newton's second law. But Ben says,
"Oh no, but that is not the case since Newton's second law hasn't been violated, since it is talking about the net force, the combined total of all of the different forces acting upon the dumbbell."
So I want to convince Ben that Newton's second law has been violated by the continual presence of force exerted by this stationary object. So my first question for him is, Ben, do you agree that these tiles do not exert any upward force when no objects are resting upon them? His answer?
Sure, so long as there is nothing resting upon them.
Next question. Do you agree that the weight does not exert an upward force when placed upon the floor?
Yes, the weight does not exert an upward force.
Do you agree that the dumbbell is exerting force upon the floor when it is placed upon the floor?
Sure, the force from the dumbbell acting on the floor is equal to the dumbbell's weight.
Do you agree that the floor does not change how much the dumbbell weighs?
Sure.
So you agree that the floor does not subtract from the force of the dumbbell? There is no 25 pounds minus 25 pounds?
Which force of the dumbbell? It doesn't make it weigh less, if that's what you're asking.
When I said the force of the dumbbell, I just meant from. The terms of and from can sometimes be interchangeable. In Spanish, it is more prevalent. I'd say, soy de Utah, which directly translates to, I'm of Utah, wherein of means from.
No, I don't agree.
An impasse is where his answer isn't enough to change my mind on the matter, and where I can't think of anything that will change his mind on the matter. But since his major concern was my use of the term of, I'll change the way I worded my question to try and get around this. Do you agree that the floor does not subtract from the force exerted by the dumbbell? There is no 25 pounds plus a negative 25 pounds?
Sure, the force exerted by the dumbbell on the floor is not subtracted by the normal force that the floor exerts on the dumbbell.
If the floor does not subtract anything from the dumbbell, making it lighter, and does not add anything to the dumbbell making it heavier, do you not agree that the floor exerts a force of 0?
I do not agree that the force exerts a force of 0 upon the weight. The floor exerts a normal force of 25 pounds upon the weight.
Do you agree that if you add or subtract 0 to a number, that you end up with whatever you are adding or subtracting to?
Yes. If you add or subtract 0, you end up with whatever you were adding or subtracting to.
Keep in mind, a little while back we did an elevator experiment where we took a scale with us on an elevator and watched how much our weight changed when the floor exerted an upward force on us.
Here goes.
Stay still, Melody, don't
I don't know what's on 8 or 4
Coming up.
or 5.
So if the weight of the dumbbell doesn't get any heavier and it doesn't get any lighter, why isn't the force of the floor considered 0 when adding the force of the floor and the force of the weight together for the combined net force?
Force of the floor being the normal force the floor exerts on the dumbbell, or the force on the floor exerted by the dumbbell?
Uh-oh, it seems like we're tripping on our prior impasse again. The word of for me can also be interchangeable with by. In the Bible, when I read the book of Daniel, that means the book written by Daniel.
Why would the force exerted by the floor on the dumbbell be considered 0? It should be equal and opposite to the force exerted on it by the dumbbell.
You asked, why would the force exerted by the floor on the dumbbell be considered 0? It is because plus or minus 0 leaves the original number unchanged. In this case, 25 pounds is the original number, which remains unchanged.
The dumbbell's weight does not change, but the net force on it does.
The net force is a combined total of all of the forces acting on an object. Our object in this instance is the dumbbell. It has a downward force acting on it, giving it a force of 25 pounds. Since that force doesn't change, that tells us nothing is adding or subtracting from that force. In other words, there are no other forces acting upon it. When that is the case, the net force is not 0. The net force is 25 pounds.
We agree that net force is the sum of forces acting on the dumbbell. The force of gravity acting on it is 25 pounds. The normal force acting on it is minus 25 pounds. The fact that the normal force is acting on it does not mean the dumbbell magically stops having a force due to gravity acting on it. The force due to gravity is still there, but there is also a normal force preventing it from moving.
25 pounds minus 25 pounds equals 0 pounds. But we both agree that the weight isn't 0 pounds.
Yeah. The weight is 25 pounds, the net force is 0 pounds.
If that is the case, then the net force is not the combined total of all of the forces acting upon it, since the weight is not 0 pounds. The net force is the combined forces, or combined weights.
Why not? Net force equals weight, normal force. Weight equals 25 pounds. Normal force equals 25 pounds. Net force equals 0 pounds. If weight was 0, then the net force would be minus 25 pounds. No, the net force is not the combined weights. It's the sum of forces acting on an object.
Weight and force are interchangeable terms. I can describe an amount of force with newtons, pounds, or kilograms interchangeably. If an object applies no weight, it applies no amount of force. Just think of a boxer. Someone who punches hard is considered a heavy hitter. And when you want to measure how much force they pack per punch, that force is measured in pounds.
No, weight and force are not interchangeable. Weight is the force on an object due to gravity, or at least that's one definition. All definitions include gravity. Forces unrelated to gravity also exist, like the normal force, or magnetism. If I push an object, the force I exert on it is not weight.
Impasse! Ben was unable to change my mind that force and weight are interchangeable terms, and I was unable to convince him that they are interchangeable terms. So, our debate is still on, should the net force be 25 pounds plus 0 pounds equaling a net force of 25 pounds of pressure? Or should it be 25 pounds minus 25 pounds equaling a net force of 0 pounds of pressure? My overall claim is that pressure in stationary objects is the thing that proves Newton's net force formula wrong. I'm not sure what else I can say or ask to convince this guy of that. But if anyone would like to participate in this debate, it is posted on our debate board and is open to the public for free. A special thank you to Ben for your participation. You've been really pleasant to talk to. And though we do not agree on everything, that is totally okay. We still have plenty of common ground that we can celebrate. This video was brought to you by the Flat Earth Institute of Science. Thank you for watching.